This tutorial is about sizing dry closed type steam condensate piping. Condensate pipe sizing is a less understood concept in the industry. This is Mosabet. I'm a registered mechanical engineer with over 30 years of experience in HVAC and utility systems. According to ASHRAE, one of the most trusted and used guidelines in engineering, there are 3 types of piping setups for steam condensate. Depending on the type, the pipe sizing is different. The 3 different piping setups per 2017 ASHRAE Fundamentals Handbook, Chapter 22, are as follows. First, condensate piping setup is a dry closed piping type. This type is the subject of this tutorial and is the most common condensate piping in industrial steam systems. As shown in this sketch, the condensate enters the pipe here, after coming out of a heat exchanger, not shown here, and passing through a steam trap assembly, not shown here. As the condensate enters the pipe, that is at a lower pressure than the heat exchanger, some of the condensate liquid turns into flash steam. A combination of liquid at the bottom and flash steam or vapor at the top flows inside the pipe toward the condensate collection tank. Since the specific volume of flash steam is a lot larger than the specific volume of liquid condensate, the pipe is sized based on the flash steam flow rate. The driving force for this type of piping setup is the pressure difference between the pipe entry point and the collection tank. The condensate pipe can run horizontally, but it is highly recommended to be sloped down toward the collection tank. The second condensate piping setup is a vented wet piping type. As shown in this sketch, for this setup the flash steam is vented to the outside and the pipe will be full of liquid condensate. This setup is discussed in another tutorial. The third condensate piping setup is an open vented dry piping type. As shown in this sketch, for this setup the pipe contains only liquid and is partially filled. This setup is discussed in another tutorial. Going back to today's tutorial, the pipe sizing for dry closed steam condensate is very easy. Let's go to Google and search for a website called papicalculators.com. I will leave the link for this website in this YouTube tutorial. Clicking on the link, the website opens. There are many different engineering calculators on this website, unique, handy and very useful. The website link can be added to a smartphone to always make these calculators handy anywhere. One of the calculators we are going to discuss is pipe sizing for dry closed steam condensate system. If I click on the link, the calculator page pops up. The calculator is good and accurate for carbon steel pipe and for saturated steam. It can be used in 2 different units, IP or inch-pound units and SI, that is metric units. I will select IP units for this tutorial. To calculate the pipe size for a dry closed condensate pipe, 4 inputs are needed: steam feed pressure, condensate pipe pressure, condensate flow rate, and either the acceptable pressure drop per 100 feet of pipe or the acceptable flash steam velocity in the pipe. As an example, I will use steam feed pressure of 100 psig, condensate line pressure of 15 psig, a condensate flow rate of 18,000 pounds per hour, and a pressure drop of 0.25 of psi per 100 feet of pipe. The calculated data are a 4-inch pipe, flash steam velocity of 4,511 feet per minute and actual pressure drop of 0.24 psi per 100 feet of pipe. If I change the pressure drop from 0.25 psi per 100 feet of pipe to 1, the results will be 3-inch pipe, velocity of 7,768.79 feet per minute and pressure drop of 0.97 psi per 100 feet pipe. The calculator will display a warning, Note 2, saying the velocity exceeds 7,000 feet per minute, not recommended by ASHRAE. Select another combination. To make corrections, we can either reduce the pressure drop or increase the pipe diameter or both to reduce the velocity. The calculator is very flexible, and by selecting different input types by using the drop-downs, it can be used to analyze existing condensate pipes or to determine the outcomes for a new pipe based on different inputs. For example, for an existing condensate pipe of known diameter, we can easily determine the maximum condensate the pipe can handle based on acceptable criteria. Let's say we want to determine the maximum flow rate for a 6-inch pipe at 5,000 feet per minute velocity in a saturated steam system operating at 150 psig with condensate pipe pressure at 0 psig. The calculated flow rate would be 13,778 pounds per hour of condensate. The pressure drop would be 0.10 psi per 100 feet of pipe. There is a note at the bottom of the calculator saying, "See recommended pipe sizing criteria" on the home page. Going to the home page and clicking on the link, the page pops up. On this page, there are separate sections with recommendations for pipe sizing for different utility systems. Going to Section 4, Steam and Steam Condensate Pipe Sizing, we will find the subsection for dry closed condensate system. It describes the dry closed piping setup, a couple of recommendations for pipe sizing, reference to ASHRAE standards for available sizing table, and a side note for properly sizing the steam traps. I would like to draw your attention to the recommendations. 1 is the recommended pressure drop to be between 1/16 to 1 psi per 100 feet of pipe. For a pressure drop greater than 1 psi per 100 feet of pipe, the velocity will exceed the maximum limit of 7,000 feet per minute. The second one is the recommended pressure inside the pipe to be equal to the pressure inside the collection tank. The last recommendation is for steam trap sizing. The trap back pressure must be set to the tank pressure plus total pressure drop inside pipe, plus pressure drop for other components. I hope this tutorial is useful for you. Please leave me comments with your suggestions to improve this tutorial. If I can help you with these types of engineering systems, please let me know. I will get back to you. Thank you for watching.